Unit 2 review, second page. Okay, so we consider this function f of x is equal to x squared minus 2x to the third. And it's asking me to figure out where this function is increasing, decreasing, and find out all coordinates of relative extrema. So in order to do that, I need to figure out where mins and maxes happen. And in order to do that, I need to figure out where is the slope of the tangent equal to 0. Slope of the tangent is just f prime. If I take this derivative, I would get 2x, 2 times 1 is 1, subtract 1 from the exponent, 3 times 2 is 6, subtract 1 from the exponent. And then I figure out where is it equal to 0. If I factor out a 2x here, I'd be left with 1 minus 3x. So here I can say x is equal to 0, because 2x is equal to 0. Divide both sides by 2, you get x is equal to 0. This one I would set 1 minus 3x equal to 0. Subtract 1 on both sides. Divide by negative 3, I get 1/3. So when you're making your chart, you're going to be going from x, f prime, f of x. And so what I need to do is go from negative infinity to the first value, or the first critical value, which would be 0, because I know at 0, f prime is 0. And then at 0 to 1/3, and I know at 1/3, the derivative is 0. And then from 1/3 to infinity. And so you're going to pick a value from negative infinity to 0, and you're going to substitute whatever that value is. Like, let's say I'm going to pick negative 100. I'm going to go up here, and this thing I know because I already factored it down below is equal to this. And sometimes when you have a polynomial like this, it's easier to factor it, because then I can see if I have negative 100, 2 times negative 100 is negative. 1 minus 3 times negative 100. Well, negative times a negative is positive, so plus 1, this is going to be positive. So when I have a negative times a positive, this whole thing is going to be negative. 0 to 1/3, oh man, that's a little bit harder. I'm trying to think of something less than 1/3, 1/4. Okay, so if I did 2 times 1/4, 1 minus 3 times 1/4. 2 times 1/4, this value is going to be positive 1/2. 1 minus 3 times 1/4 is 3/4. If I subtract this, I get 1 minus 3/4 is 1/4. And even if I didn't know that, I know this positive times positive, so this is positive. 1/3 to infinity. If I put in a positive, let's say 100, this value is going to be 2 times 100, get positive value. 1 minus 3 times 100, this is going to be a negative value. If I multiply a positive and negative, I get negative. Which means if f prime is negative, that means f of x is decreasing. And if you have a tough time with that, instead of saying f prime, substitute in the derivative, or if that's still difficult because it doesn't quite seem as conceptual, what about just say the slope of the tangent is negative? Okay, slope is negative, the function is decreasing. Slope is positive, that means f of x is increasing. Slope is negative, that means that f of x is decreasing. And then you could say decreasing to increasing. Decreasing to increasing, here there's a min. Increasing to decreasing, here there's max. I'm not going to go through the rest of it and writing it out. It's just saying, if I'm justifying all this, I would say f is decreasing from negative infinity to 0 and 1/3 to infinity as f prime is negative. F is increasing from 0 to 1/3 as f prime is positive. And then f has a min at x equals 0 as f of x is changing from decreasing to increasing, or f prime is changing from negative to positive. F of x has a relative max at x equals 1/3 as f of x is changing from increasing to decreasing, or f prime is changing from positive to negative. A little bit of caution in the last one. I said that those values of x at 0 and 1/3, but in the directions it says find all coordinates. Coordinates mean that you have an x and a y value, and it's the function value. This is the min and max on the f of x. So what you're going to do is find f of 0, and I'm going to go back up here. So 0 squared minus 2x, or 2 times 0 cubed. And I get 0. So at 0, 0, that's where there's a relative minimum. If I substitute f of 1/3, and I say 1/3 squared minus 2 1/3 cubed. Okay, 1/3 squared, you square the numerator and the denominator, so I'd have 1/9 minus 2. And this one, I'm going to cube the numerator, which would be 1, cube the denominator, which would be 27. So right now I've got 1/9 minus 2 27ths. I'm going to multiply this by 3 over 3, so this would become 3 over 27 minus 2 over 27, and I get 1 over 27. So that means at 1/3, 1 over 27, this function, f of x, has a maximum. Those are the coordinates. So you're plugging back into f of x if you want to find the actual coordinates. These values are plugged into f prime. Number 4. I think I went up too far. Yeah, I'm good. Okay, in number 4, we've got this derivative, and we say f of 3 is equal to 7. Approximate the value of 2.9 using the equation of the tangent line. I can't possibly approximate the value of f of 2.9 using the tangent line unless I have the equation of the tangent line. To find the equation of the tangent line, you need 2 things. Say them out loud. They are, yeah, you got it, a slope and a point. The point is f of 3 is equal to 7. It's written right here. It's already given. The slope is f prime of x, x squared minus 4. This is the slope for any point or value of x. But this is specifically, I want to find out what is f prime of 3. So I'm not doing anything with a 2.9 until after I have the equation of the tangent line. 3 squared minus 4 would be 9 minus 4. I get 5. Okay, equation of a tangent line, 2 things, a slope and a point. So I'm going to say y minus y1 is equal to m. That's the slope of the tangent line, the derivative, x minus x1. So I did all this work, and then it says approximate the value of f 2.9. Once you have the equation of the tangent line, then you can substitute in 2.9. Then you're going to solve this. I'm going to say f 2.9. 2.9 minus 3 would be 0.1. It's going to be negative 0.5. If I add 7 to both sides, that'd be 7 minus 0.5. I get 6.5. So if I want to know what f of 2.9 is, it's going to be approximately 6.5. And the reason for this is just because a tangent line is very, 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 very close to the function value at the point of tangency. And 2.9 is super close to x equals 3, so this is going to be super close. Okay, so number 5. It says sketch the graph. Oh, this one. Oh, you know what? I'm going to use this piece of paper on this one because it doesn't matter if it bleeds through. Okay, so it says sketch the graph of f of x. And you're probably thinking, oh no, I don't have a calculator or anything, because in this part you wouldn't. So hint, hint, make sure that you know this. F of x is equal to x cubed minus 3x squared. Then the next part says, at what point does this graph have f of x have a point of inflection? That's kind of rough because we don't know what that is yet, but you will, and it's easy. Label this point and find the coordinates by finding the midpoint of the relative extrema. Okay, so midpoint of relative extrema. You don't have to know what the point of inflection is. You just have to be able to follow this. You're finding the midpoint, the value in between relative extrema, meaning mins and maxes. X cubed is going to look something like, ooh, that's terrible x cubed. Like that kind of, there's going to be like 2 loop-de-loops. So what I'm going to do is I'm going to find f prime of x, because, you know, that's what we do in calculus. Because this is going to help me find mins and maxes. So I get 3x squared minus 6x as the derivative. I'm going to set that equal to 0. And so when I do that, I can factor out a 3x. I'd be left with x minus 2. So I can see at x equals 0 and at x equals 2, those are going to be two important points. Like they're going to be either mins or maxes or horizontal tangents, but because right now they're definitely horizontal tangents of some sort. But I'm going to go back old school, say x and f of x, and just make a table. When I have x is 0, 0 cubed minus 3x squared, so 3 times 0 squared, I would get 0. So I have a point right here. At 2, I can see 2 cubed would be f of 2. 2 cubed minus 3 times 2 squared. 2 cubed is 8. 2 squared is 4 times negative 3 is negative 12. So this would be negative 4. So at 2, negative 4. So those are pretty important points. But now I'm going to figure out what else is happening. So I'm just going to pick another one. Like what's happening at x equals 3? 3 cubed would be 27. I'll write it over here this time. 27. 3 squared is 9. 9 times 3 is 27. So I get 0. So at 3, 0, something's going on. But I know that this one is either going to be a min or a max. This one's going to be a min or a max. And so let me find another one. How about, I don't know, negative 1. I'm going to write this over here somewhere. Negative 1 cubed is still going to be negative 1. Negative 1 squared is going to be 1 times negative 3. F of negative 1 is negative 4. So right now, I know this is hard to tell, but I don't know what's happening here, but I do know this is x cubed. So I know enough right now. If that is potentially something, this is potentially something. If you said, Miss DeWald, I would not have known to do that. Pick some more points and just know that this one would have to be a min or max. This would have to be a min or max. The other option that you have is to go through and make the rest of the chart and figuring out what's happening in between there. Is the function increasing or decreasing? And do it that way. These are the 2 points that I'm going to be looking for. Okay, this next thing says, so I sketched a graph here. At what point does it appear that the graph of f of x, has a point of inflection? So I do this by finding the midpoint of relative extrema. So one of these would be right here at 0, 0. And the other point, or the relative extrema, is at 2, negative 4. So I'm going to use this area up here. But in, I don't know, algebra 1, midpoints you find by taking the average of the x values, so 0 plus 2, dividing by 2. This is going to be the point, 1. So my x coordinate is going to be 1. This would be like y1 plus y2 divided by 2. If you're thinking back to those formulas, this would be 0 plus negative 4. I'm finding the average of the y values. 0 plus negative 4 would be negative 2. Over 2 would be negative 1. And if I go to 1, and then I think I might have done it wrong. Ooh, let me look again, because negative 1 didn't make sense, so I looked again. Negative 4 divided by 2 is negative 2. I'm pretty tired. Okay, 1, negative 2 is right here. And it said label this, so I'm going to say this is the point of inflection. So if you're saying, yeah, I'm labeling this, but I have no idea what it is. Points of inflection are where a function changes concavity, and we'll do this a lot later. So this is a concave down function. Concave up is like this, like a frown. Oh, I'm so sad, concave down. A smile, concave up, I'm happy, yay. This point where you can't really tell if it's a smile or a frown, this is the point of inflection. That's what's happening here. But even if you didn't know that, you could still follow this and say, okay, yeah, I get this. This is the midpoint of relative extrema. Okay, next thing. I lost the other paper. Hooray, I found it. Okay, so we've got this derivative and set this equal to 0. Okay, so it says f of x is equal to x cubed minus 6x squared. And it says, find the derivative of the derivative. What? Okay, so I'm finding the derivative. And then I'm doing it again. And then I'm gonna say double prime up here. And then it says, set this equal to 0. I'm gonna add 12 on both sides. And so it says graph f of x on a calculator. So on y1, put this into y1, and then you're gonna graph it so you can see the curve. So zoom 6 probably should work, but if you need to expand a little bit, change your window. And it says, what do you think you are finding when you set the second derivative equal to 0? And so what I want you to do is stop this for a second, look at that, and see what you're finding. Okay, welcome back. At x equals 2, you should see that same thing that we were talking about a second ago. That x equals 2, there's a point of inflection. So, very exciting, and we'll do more with this later, but it is important because you're going to be walked through the same process on the next test, on Unit 2 test. Okay, number 7. 7 says, when you are asked to find the slope of the tangent line of a particular value x, what are you being asked to calculate? The slope of the tangent is the same thing as, you should be thinking, the derivative, or f prime. So derivative, f prime, either one goes in there. That's the same thing as slope of the tangent. This thing, the formal definition of derivative is the limit. So number 8, that is the limit as h approaches 0 of fx plus h minus f of x over h, or if we're talking about the limit as x approaches a, both of these are like y2 minus y1 over x2 minus x1, but because this says the limit as h approaches 0, this is for any function. Whatever is right here, that's my function. And so you don't have to do this the long way. You can just say that this is equal to f prime of x. This one, if you see something, you're like, wait a second, this is at x is approaching a, x approaching 1, I don't know. Recognize that this is the function, f prime of x, and then substitute in whatever that value of a is. So to give one more example on this, for instance, if I said the limit is h approaches 0, and I said something like, I don't know, the cubed root of x plus h minus the cubed root of x over h. What I'm actually trying to find is f prime of x. So I would take this thing, that is my f of x value. So if I look up here, and I would rewrite it. The cubed root is the same thing as x to the 1/3 power. So if I'm finding the derivative of this, I get 1/3 x. 1/3 minus 1 would be negative 2/3. I can rewrite that. And if I wanted to, I could rewrite this as 1 over 3. And then this means x is going to be squared. This would be the cubed root. I don't care which way you write it. I think actually this one's a little bit more clear than this one. So this is a different way to recognize you do not have to do this a long way. In fact, this would be really crazy to do. So we don't want to. We just want to recognize that this is the function f of x and then take the derivative. Okay, the next one, the 9 says, if I know that I'm being asked to find the derivative, the question is given to me in limits. Can I do it the easy way or just use the power rule of trig derivatives of mention? So this thing, that's what I'm talking about. This is the easy way. Okay, the next one, find f prime of x. So all this is practicing this. And number 10. So this is A. And the first one, and it says find the relative min and max of each. Only do this if you feel like you need help on each part of this. So what I'm going to do is I'm just going to go through and find the derivative. If you wanted to find the min and max, you would have to continue this and then you can make a chart, figure out where's the derivative changing from positive to negative. Okay, and the first one, I know f of x is 3x cubed minus 4x. I can use the power rule on this, so I don't need to change anything about it. Let's say 9x squared minus 4. Took the exponent times the coefficient, subtract 1. Here the derivative of negative 4x, or the slope of negative 4x, is negative 4. Again, if you want to figure out mins and maxes, you would have to make a chart. In part B, f of x is written as 3 square root of x. I'm going to change this and say 3x to the 1/2 power. Because now it's written in a polynomial type form. It's not exactly officially a polynomial because you can't have fractional exponents, but we'll go with it. 1/2 times 3. Oh, I can still use the power rule though. 1/2 times 3. Subtract 1 from the exponent. 2 times negative 7. It's negative 14. And then I would have x to the first power. I would just want to rewrite this one so you can see this. This would be the same thing as x to the 1/2 in the denominator. This is all f prime of x. And be really careful about labels. If you had to put this as a single fraction, because that might be a multiple choice question, what you would do is you would have to take this and say, okay, well, I want common denominator, so this would have to be over 2 squared of x also. In order to do that, you'd have to multiply the numerator by 2 squared of x. Now you'd have f prime of x was equal to 3 minus 14 times 2 is 28. Square root of x, or x times square root of x. Really, this would be like x to the first power. This would be x to the 1/2 power, so I could add them together. X to the 3/2 power for 2 square root of x. Kind of gross, but that works. Okay, in part C, the way that this is written right now, you can't take x to the 4th plus 2x to the 3rd plus 5x. You don't try to take the derivative of the numerator and denominator. It's not a thing. What you need to do is say, well, x to the 4th can be divided by x cubed. 2x cubed divided by x cubed. So can 5x. And then you can rewrite it. X to the 4th over x to the 3rd is just x. This would just be 2, flip away, plus this one would be 1 minus 3, so I get 5x to the negative 2nd power. Now you can take the derivative. So the derivative of x is just 1, because there's a coefficient of 1 here that's not written. The derivative of 2 is 0. The derivative of 5x to the negative 2nd power, negative 10x. Subtract 1 from the exponent. If you want to rewrite that, again, if you want to put this as a single fraction, you can multiply this by x cubed over x cubed. X cubed over x cubed. So this would become x cubed minus 10 over, but you don't have to. We're on the last page. Woo. Okay, I'm gonna use the same piece of paper because I'm kind of running out. In part D, it says x cubed plus 4x. I'm going to do the same thing that I did last time. But instead of saying, well, I'm going to divide this by the square root of x, I'm going to rewrite it as x to the 1/2 power. So this would be the same thing as 3 minus 1/2. 6 over 2 minus 1 over 2 would be 5 over 2. This is x to the first power, x to the 1/2 power. This would be 4x to the 1/2 power. And this would be really easy after doing all this work to say, hey, I'm done, but you're not, because you didn't actually find the derivative. So make sure that it's f of x is labeled the whole way through. F prime of x, now I can use the power rule, 5/2 times x. Subtract your exponent by 1, so 5/2 minus 2 over 2 would be 3 over 2. 1/2 times 4 is 2. Subtract your exponent by 1 is negative 1/2. And again, you can rewrite this. This one you can write x to the 3rd power and then take the square root. This is always the power. This is always the root. x to the 1/2 in the denominator is just 2 over square root of x. And then one more on this page. Oh wait, no, 2 more. F prime of theta. The derivative of theta, I know that's hard to see, but you have the same paper, is just 1. Because it has a coefficient of 1. The derivative of sine is cosine. And I can just bring this 2 along. I would suggest going through this one and figuring out where the mins and maxes happen. You know, just because it would be a good one to do. So, mins and maxes. Okay, f of x. I'm rewriting this. Instead of saying the cubed root of x, I'm going to rewrite it as x to the 1/3. Because then I can say this would be 5x. If this is 1, 1 minus 1/3 would be 2/3. Or f prime of x is 2/3 times 5, which would be 10/3. 2/3 minus 1 would be negative 1/3. So I would rewrite this as 10 over 3. I could say x to the 1/3, or I could say cubed root of x. In number 11, it says for any function given in number 9. So number 9, let's go back there. This is talking about the easy way. Oh, this should say given in number 10, not number 9. So change that. How do you find the slope of the tangent line at x equals 2? The slope of the tangent line is just the derivative. So whenever you were finding f prime of x in all these problems, like here, you would substitute an f prime of 2 in all of those problems. And it says, how do you find the slope of the normal line? Normal lines and tangent lines are perpendicular to one another. So think about perpendicular. So their slopes are going to be opposite reciprocals. So whenever you find the slope of the tangent line or the derivative, if you want to find the slope of the normal line, just find the opposite reciprocal. Okay, last problem, number 12. This table below represents the graph of the derivative, values on the graph of the derivative of h prime. So it's listed here as h prime, so we know that we're looking at a derivative. But as you see where it says of a polynomial function, as soon as you see this polynomial function, you've got to be thinking, yeah, this function is continuous. And it also says the zeros indicated in the table are the only zeros of the graph of h prime. So what you need to do, and I kind of ran out of some of the space here and I should have used it otherwise, but at -2, I can see that h prime is 0. So this is one of my critical values. Same thing over here. At 7, I get 0. So what you need to think about is, okay, well, what interval is the derivative positive and negative? On this graph, on this table, the next step is already done for you, where you're picking a value. You just have to figure out that the intervals are from -∞, because it's a polynomial function, to the first critical value. So not -5, it's going to be at -2. Same thing here, -2, because I'm going from this critical value to this one. Then from 7 all the way to infinity, because this is a continuous polynomial function. On this interval, I can see 11 and 5. That's what I get if I substitute in -8 and -5 into h prime. So I can see the derivative here is positive. Here, negative, negative, negative. This derivative is going to be negative. 7 to infinity, negative. If you ever see one's positive and one's negative, you did something wrong with your intervals, because it will always be the same sign in whatever intervals you chose, like 7 to infinity, -2 to 7, negative infinity, -2. If I want to know where h of x is increasing, all I have to look at is where h prime is positive. Where h prime, I'm not going to write all these because I'm going to run out of room. H prime is greater than 0. I can see that happens from -∞ to -2. And that's it. So just on that interval. Decreasing, I can see that that's happening when h prime of x is negative, which occurs when on the interval from -2 to 7. Also in the interval from 7 to infinity. You can't just say -2 to infinity, because at 7, h prime of x is equal to 0. And this would be like if I'm going negative and then it evens off for a little bit and then negative again. It kind of levels off for a little bit. Relative maximum, well here, positive to negative means increasing to decreasing. If I said h of x down here, I would have a max. I should also do the other ones, increasing, decreasing. So I would say h of x has a relative maximum at x equals -2 as h prime changes from positive to negative, or you could say h of x changes from increasing to decreasing, because you already gave that whole spiel about h of x when it's increasing and decreasing. In this part, I would say you can see there's nothing crazy happening here, decreasing, decreasing. At x equals 7, h of x does have a horizontal tangent. It also has a horizontal tangent at x equals -2. It's just more specifically a max. But at x equals 7, there's a horizontal tangent, but that's it. So you would have to actually write out that h of x does not have a relative minimum, as h prime never changes from negative to positive. It's really, really important. If there is no relative min or max, which in this case, no relative min, you actually say why there's not. So you have to justify your reasoning for that. And this one, it says, using this chart, so same chart, what is the tangent line approximation? Okay, so tangent line. In order to do a tangent line approximation, you must first need a tangent line, which means you need a slope and a point. If my point is at h5 of -2, this is my point, my slope of the tangent is going to be h prime of 5. I'm not doing anything with 5.1 yet. H prime of 5, if I go up to this graph, it's listed as -1. So then I can say y minus y1. So y minus -2 be y plus 2. Slope of the tangent, where the derivative is -1, x minus 5. Here's where you can substitute in 5.1. So y plus 2 is equal to -1. 5.1 minus 5 is 0.1. So I've got -0.1 times 0.1, so -0.1. Here I'm going to subtract 2 on both sides, so I -0.1 minus 2. So my tangent line approximation is -2.1, which is pretty close to the point at h of 5 is equal to -2. Okay, thanks so much. Study lots. Message me on Remind or come see me if you have questions. You can do this. Practice a lot. Don't just try to wing it. And see you tomorrow. Bye.